Welcome to Breadboarding. This is video 12 in the Breadboard 8088 PC series, and in this video what we're going to be doing is adding a serial port and extending the monitor to be able to do loading and saving S-record files over the serial port. So if you just take a look at our block diagram, and we'll look at where we left the project, and then we'll see what things we need to add the serial port. So this is a diagram of the computer as we last left it. So we added the 7-segment LED display and keypad and the associated peripheral interface adapter. Now, in order to be able to do serial communications with PC, we need to be able to add some form of serial communications. Some designs will use the old RS-232 standard, and that did require plus or minus 12 volt supply. But in fact, with modern PCs, quite often the USB serial adapters will work with 3.3 volts or 5 volts. So we're actually going to be using one of those. What we're going to do here is to use a Motorola serial port initially. So the reason for this is that the Nanocomp monitor that we've migrated over into the 8088 CPU already supports this, and so this will actually probably work quite well initially. And what we're going to be using is a USB to serial converter based on the FT232 series chips, which are very standard chips for doing this type of thing. And that's going to connect to the PC over a USB cable. We're going to need to add a crystal clock oscillator. Now, the frequency that we choose will depend on what baud rate we want. Now, in the previous Nanocomp project, I used the 3.6 megahertz crystal, and when that was divided by 64, that gave us 57.6K. Now, the Nanocomp worked quite happily at that frequency, so I'm going to try with this frequency first. So let's take a look at the chips that we're going to be using and the devices we're going to be using. So this is the Motorola 68B50. So the B version of the chip is capable of going at 2 megahertz system clock speed, 8 megahertz clock speed. So this should be more than fast enough to keep up with everything. And this is an example of one of the FT232RL boards. Now this particular one, I bought it from the local suppliers, doesn't include these pins here, but did include these pins here. Now the only problem, as we found in the Nanocomp 6809 series, is that one of the signals that we need for doing hardware handshaking is not actually available on here, and we'll talk about it in a minute, but it is available on these pins here. So all I've done is I've soldered in these pins into this, and this will allow the board to fit into the breadboards. We just need to make sure that the USB socket is actually in the right location. And what this would allow us to do is, if we wanted to, we get access to the full range of pins on here. I'll talk about what those are when we look at the data sheet. And then these are the two crystal oscillators that I've got. So there's the 3.6 and the 1.8 megahertz versions there, so they should be interchangeable. Just need to make sure that we plug them in the right way around, as I have broken a number of these by not plugging in the right way around. So this is the version 1 diagram that should have been uploaded onto GitHub under the 8088 breadboard PC area. So this was the peripheral interface adapter and the display and other supporting chips we added previously, and all we're going to do is on the same board we're going to add the 6850 UART, asynchronous communications interface, the various acronyms used for this, but the serial chip we're going to add over here. We're then going to put the crystal starting with the 3.6 megahertz one here, and then we'll just plug in our serial converter board on the end here. Now I just do need to make sure that the pin direction makes sense with the USB converter. Now you can see here I've tried to put in as many of the pins as possible. There were 1 or 2 pins were actually potentially mislabeled. This is a document I used to try and work out. So pin 17 had RSD on it, and I believe that should be DSR. There isn't such a pin label on here, so the screen printing on the converter wasn't quite right. And I've added a component in the Breadboarding Labs symbol library here for this. So in fact the end connector has DTR and clear to send, so request to send is the extra signal that we need in order to do the handshaking. Now we're just going to wire this up. We can just wire up the bus signals with the 6821 peripheral interface adapter, and apart from the chip enable, so if you look at the chip enable, this is the COM0 chip enable coming out of our decoder over here. Apart from that, most of the other signals can come across from here, so we just need to wire things like the register select to the A0 line over here. So what we're going to do now is to wire this up on the board, and then when we come back we'll have a look at the software and what we need to convert it over into 8088. Okay, so I'm just going to tidy up things, move a few of these cables out of the way. I think I'm probably going to have to move the keypad and the LED display on the other side of the board here, so for the moment I'm just going to unplug these to clear the space a little. And since we're going to unplug this, we'll just unplug that from there. Okay, so just move those out of the way. Okay, so I'm going to lay this out. We just need to put the serial USB converter over here. Now, I just need to make sure that that will clear the breadboard buddy there, and then we'll just want to make sure that the chips will fit. So this might be a little bit tight to get everything in. Might possibly need to unsolder those or bend them upwards. Might be a better bet. And this is the 3.8 megahertz version, so I think we can fit that in there okay. It's just that these pins, I think we may even need to bend upwards. So what I'm going to do now is I will stick the chip label on our 6850 communications interface, and I will then speed this up. I'll comment over it, and when we get back we should be ready for it to be wired up and plugged into the Nanocomp. So I straightened the pins on the serial adapter. We just put on the label. I'm just going to put in the power leads and the decoupling capacitors. Needed one there, ground for the USB connector. So this is putting in the E and the read-write signals and A0, register select, the chip enable highs and the chip enable low to the output of the decoder. We just need to do the receive, transmit and clear to send, request to send, and then the clear to send to request to send and the clock. Now we need to do the data lines and just move the cables so they're out of the way of the chip labels. Okay, so finished wiring in the serial port and the USB serial converter in there. I've moved the keypad around and I had to extend one of the cables a bit to fit over here. And there were just two things in addition that I had to make. I'd missed out the ground connection for the serial converter. We don't want to connect 5 volts anywhere on here, otherwise it means that the PC may end up powering the whole circuit here, which we don't really want to do. And there was also the data carrier detect. It needs to be tied low just up here. When I checked back on the original Nanocomp diagram, so this is the Nanocomp 6809 diagram, we can see here data carrier detect is tied to ground here. So I updated the KiCad diagram, so you can see now that data carrier detect is now wired to ground, and there's also the ground connection over here. That was the only change I needed to make. So for our asynchronous communication interface adapter, or UART, various terms can be used, we've got register select control between the control status port and also the data. We can do clock divide by 1, 16 or 64. So initially we're doing 64. That will give us about 57 kilobits per second. And it is possible to do interrupts on the transmit data register empty or the receive data register full, which are the two indications that either we've got data coming in or we need to send more data out. But for the moment, because we're just polling these, we don't need to bother with the interrupts. And then because we're using our FTDI FT232 adapter, these were the pins that we needed to connect. Now originally the pins on the end of the adapter was DTR, and in fact we need RTS, not DTR, and so this is the reason why we've soldered in those other pins. And basically you've got obviously ground to ground, but because we've got 2 bits of data terminal equipment being connected together, we need to cross the signals over. So clear to send goes to request to send, transmit goes to receive, receive goes to transmit, and request to send goes to clear to send. So we have to make sure we do that crossover, otherwise it won't work. So let's now take a look at the software that we needed to convert and update the monitor. So in the original Nanocomp monitor, there's the load and save routines, and I think there's a total of about 260 odd lines of code in there. We excluded this from the conversion when we did the first version of the monitor. So all I've done is I've copied all this, so that it's in all the messages. So we've got down here 267 lines of that being copied over into the monitor here. So we now have version 2 of the monitor, which has got the save and load SREC, and I've also removed some of the initialization of the RAM, because if I'm loading stuff in, I don't want to have the RAM reinitialized every time I do a reset. And what we've done now is to add some of the constants for the ASCII values that we'll be transferring. We've got the various serial port constants for the port, the control port, the status port, which are actually on the same address, but I found it easier to know whether we're doing control signals or reading status signals. Just makes it a little bit clearer. Then we've got the various bit combinations that we need for doing reset, divide by 16, 64, and the various other settings. And then there is the status register. And the things we're particularly interested in are the data register full and the transmit data register empty. Those are the two bits we're primarily going to be interested in, because that tells us whether we need to send more data or if there's data ready to be received. And then there's a couple of memory locations. When in the monitor we press save, we need to put a start address and a finish address. So we're just storing those in two memory locations allocated to the monitor for the moment. So I won't go through in detail the conversion. It was relatively straightforward. Again, making sure the segments and things are correct is a little bit tricky. There were a couple of gotchas. One of the ones that took me a while to get to the bottom of, the way how the 6809 can do returns from procedures is because the pull from stack instruction allows you to also include the program counter or the instruction pointer. Then you can actually do a return in and pull all the registers in a single instruction. And I'd missed out the return here, and so what was happening is it was then going through to the rest of this code here and actually returning an error. It was doing this error, and it took me a while to get to the bottom of. When I was finally reviewing the code again, I realized I'd missed out this here. So again, the save routine, what we have got here at the moment, I've got the divide by 64 is actually enabled at the moment, and if we have time I'll try the 1.8 megahertz clock and see if we can get this running at 115 kilobits per second, or kilobaud. Okay, so that's the code that we need. There's a couple of messages down here that is the sort of end of file message, for example, is just as a message here. So that's all ready to be burnt into the ROM. So just get the command line from the top of the file here. So NASM building the binary output of this. Okay, we just got the warnings about the padding. So I'll burn that to the ROM. I won't show that in the video because I've done that a number of times already. So we'll burn that into ROM, and then we come back, I will start testing this. And what we're going to try and do is to test the SRecord files. First of all, I have got a fairly simple Hello World program that I've done here where I've got the SRecord version of this. So this is an SRecord file. It begins with an S1. Then it has the number of bytes, the address, the bytes, and then a checksum at the end. I have got a number of variants of these, which we'll look at when we're testing this. So the SRecord format, there's a Wikipedia article on it, and basically S1 records are 16-bit values with data, and S9 is the end of file. And I think there's also an S0 is produced by the NASM assembler, which is just the header comment, which will be ignored. Now the LED display is expected to show F for finished. If there's a checksum error, then we'll get a C for checksum error, and if there's a hexadecimal conversion error, we'll get an E for that as well. So I have got a couple of error files that I'll try this out and we'll just make sure that it's working properly. So I've updated the monitor ROM here, and we're just going to plug in the USB serial connection to the PC. Again, if we were to plug in the 5-volt line here, then the whole board will then get powered by the PC. And I'm just going to switch on the... So we have there, we've got Nanocomp 8088, and this is version 2 of the monitor. So this has got our updated code in it. And you can see down the bottom, we've got about 4.76 volts down the end here. So it's okay. It's not great, but 4.7 volts is well within range for everything. So first, we're just going to download a very simple file. So all I've done is I removed all the other data. So we just got a hello S9 rec. So it's a very simple file. Just going to copy that file path to the clipboard. We'll run up the terminal emulator. This is a real term. And we'll just get ready for sending that. There we go. So that's all ready. So we'll just go back to the Nanocomp. So I'm just going to hit load and the display goes blank. I'm now just sending our S9 record, and we've got F there, which means it's finished. So that's good. Hasn't actually transferred any data. It's just done a very simple test there. So for now we go into load, and I'm now going to send down the hello. Again, that seems to have finished. So we'll just inspect the memory. So we have a couple of no ops it begins with, then BFF0. I think this goes all the way up to about 3435, should be ending on about F9. F934 ends on F9. So that seems to have loaded okay. So now we'll try some of the error files. So just going to try one with an invalid checksum first of all. So here's one of the checksum error. So I've updated this checksum from 20 to 21, so it's an invalid checksum. Okay, so it's waiting, and when we send file, there we go, we've got a C for checksum error. And then finally, we'll just do the same thing for, this is one with a hex error. So what I've done here is I've just swapped out value here for an X there. You can see that it's also invalidated the checksum as well anyway. So I think it will come up with a hex error before it gets to the checksum. So it's waiting for the next file, just going to send it. And there we go, we've got an E for an error. So it looks like the code has come over. Apart from that return that I missed out, then most of the code wasn't really an issue. But other than that, then that all looks like it's working okay. So we just now need to check to see, let's just go to memory 0034, and that is F9. So what we now need to do is to upload this. So we're going to save it. So we're going to save 0000 to 003, and this will send as soon as I press the 4. So just go back to the terminal emulator. And what we will do now is we'll capture this so we can actually see if the contents we get match the other file. So I'm now just going to press the 4. Okay, and that has finished. We stop capture. Open this file. Okay, so it's a slightly different format. It's done it in slightly fewer number of lines. And if I just save this as an SRecord file, you'll see now that because it's an SREC file, then it's interpreted it. So if I did a WinMerge comparison of these, they're obviously different because this has got a fewer number of bytes on each line, but it is a valid SRecord file. And it does look like the F9, EBF9 at the end there, EBF9 at the end there. So it looks like it's all working. So it looks like the saving and loading to serial port is working. Okay, so that looks like it's all working okay. We've now got version 2 of the 8088 Nanocomp monitor running we can now download programs and save programs back up onto the PC. There was a minor problem in running the Hello World program that I did, which I'll need to look into, and we'll run the Hello World in some future videos. It's related to stack handling and the executing the Go command execution. So I'll have a little look at that. So that's the serial port and the S-Record load and save to the PC done in the monitor. We don't need to worry about the Intel hex file format because S-Record is produced by the NASM assembler, and we've also got command line utilities to convert binary files into S-Record. So in the next video, what I'm going to be looking at doing is starting to build a monochrome display adapter video controller on breadboards. So this will be similar to some of the video controllers I've built on the Nanokomp 6809 series, but we will be trying here to make one which is compatible with IBM PCs and with DOS, so that any software that's able to run on a DOS should be able to work with this video controller. So that's probably going to take a number of videos to go through all of that. So if you don't want to miss out and you want to know how to build a video card on breadboards, then please subscribe, and if you found the content interesting and useful, please hit like. It just helps to make the videos available to a wider number of people. Thanks for watching.